The floor is yours.
Thank you very much for your kind introduction, and thank you for allowing us to present our own results. At the very beginning, I would like to introduce the co-authors. Mr. Unfa, he's a fish biologist who for 15 or 20 years has been dealing with fish migration. And Mr. Zaheringer is a hydraulic expert. He's an engineer who covers the abiotic aspects and learned to think how a fish, learned to think like a fish so that he can identify with him much better. I would like to give you an overview of what happened in Austria in recent years during the implementation of the Water Framework Directive. Austria decided to focus on the continuum. First of all, we've got less money than Switzerland, although we're bigger, but it's still 140 million euros that we invest, and 70% were invested in connectivity. And this was a decision which was recommended by the experts because continuity is essential for a water body. There are many presentations, and I remember that 20 years ago we talked about a few hundred barriers. Then the number increased, and now we're talking about hundreds of thousands. We're also counting diligently in Austria, and you see that we have reached almost 40,000 barriers that interrupt the rivers and streams, but we have built also quite a number of fish passes and fish facilities. But a large number is not passable. 273 however, provide only a limited functionality. So there are also many rivers left that don't have any fish passes at all. The concept, and this is repeating something that has already been said, well, this is a networked world. All technical colleagues know what's happening elsewhere in the world. And it's very interesting to see that there are similar maps of different countries, that is Germany, Austria, and Switzerland. We also prioritized the rivers. Where is the problem most pressing? This is, for example, the Danube salmon, and this was a reason to establish this map to determine priority rivers which would be covered in the first plan for restoration. As a matter of fact, this process should be finalized by 2015. This is something we need to take into account. We also cover a big river basin, not the River Rhine, that's only a small part. But as a matter of fact, we've got the Danube River Basin, and it doesn't make sense to think about connectivity, but be aware of the fact that there is a barrier in the lower part, so that, for example, sturgeons cannot migrate upwards. So we are cooperating closely with the Commission for the Protection of the River Danube. And as a matter of fact, this was practically copied from them. And we ensured that within the entire Danube river basin, not covering all 100,000 barriers, but just the most important one, were taken into account in prioritization. And then it turned out that there is a specific hotspot where we have to start in Hungary and in Austria and at the bigger tributaries. This is where restoration would be absolutely necessary. The position of the barrier was used as one criterion, but the distance is also important. So how much can be liberated, so to speak. This is relevant for the prioritization index, how much habitat can be reconnected, what is the status of that habitat, is it protected, and can I expect a more positive effect in that case than in other cases. And in the conclusion, this means that of course, we are focusing on connectivity, but this must be embedded in an overall restoration. It doesn't make sense to focus on fish and migration and ignore the rest of the ecosystem. The Austrian guideline, I can present it very briefly because it was developed in parallel with the German guideline. There was an intensive exchange between the German and the Austrian working groups. We both had a very long process. We had a proposal by the working group, then it went through the stakeholder process, the political process, and in the end it took us 20 years of discussion, and I agree to 100% with Mr. Heinen, the previous colleague. This is only a guideline, and not every specific situation can be covered by such a guideline. But we saw that there are so many fish passes that were built and don't work at all. And we wanted to ensure that this would no longer happen in the future. And therefore, these guidelines are very important. They should help you in planning. They should guarantee high functionality of the fish passes. And if the connectivity is the only problem of a river, the good status or the good potential should thus be ensured. And this is something that we should never lose sight of. This is important within the framework of the Water Framework Directive. And this is the objective of the measures and of the funds that are being invested. I'm just giving you a few pictures. We also did some classification of the different types. That's very similar. There might be different terms depending on the region. But as a matter of fact, there has been a certain consolidation, and the terms are also quite similar. And the basic principle that we take into account the size of the fish that was accepted by both working groups, finding of the entrance, passability of the fish pass. This is something that is also included in our guideline. And the wish of the practitioners was to have concrete figures. Planners asked for it. And if you know that, of course, you can't calculate it to the very last millimeter, you've got difficulties with these limit values, but still it is a guideline for planning. Of course, that must be adapted to the fish types. For us, the Danube salmon is very important. That is relevant for the size of the fish pass. Let me go through the table. Of course, this will be available, and as a matter of fact, the guideline can be downloaded free of charge from our ministry. And if there are any specific questions, Mr. Müllmann is also here. He's the representative of the ministry, and you can ask him. We all agree that the attraction flow includes some open questions. As a matter of fact, this is something that we have to focus on with respect to upstream migration. We've got the very same limit values. They can be found in literature. I'm afraid, however, that there is relatively little research in that respect. So we do need a number of additional studies in order to answer some questions, such as attraction flow at different water levels. We sometimes deal with water level differences of 15 meters. How do you build a fish pass in such a case that would work with any water level? This was also mentioned, the operation of fish passes. This is something we need to focus on. It really doesn't help if it works under excellent conditions, but after a while it looks like this, and it's quite clear it wouldn't work. More than 1,000 fish passes, some of them enormous, several kilometers long, which is more than a fish pass. They become a habitat. And especially when you have one sluice after the other, it is very important. So the question is, should we build a new channel, or should we do something else? I think we have to think beyond migration, but think of habitats and systems, bypass systems that are 20 or 30 kilometers long are a kind of substitute habitat for natural habitats that were lost. And it's very important that the knowledge which we have got in Central Europe is passed on, especially in the Danube region. This knowledge transfer is of great relevance. And I'm afraid this is an older paper, but we've tried to translate the most essential findings into English so that the other states would be able to utilize our knowledge as well. Downstream solutions, we're only at the very beginning in Austria, I'm afraid. There is a project initiated by the responsible ministry where we also want to work on this issue. At the moment, we are collecting the important questions for Austria. We don't have any diadrome species anymore, so the focus is on different species. But in principle, we've got the same problems as for other species. We are trying to be very pragmatic. These are some cases that we examine within the framework of the study. We will examine it. Just one, for example, this is an existing power plant with a fishway, and we are asking ourselves whether the downward migration could be covered by way of this existing fish facility, or whether we introduce a screen or rake before the turbine in order to guide the fish. But in the River Elbe, we found that not only during the spawning period, but also during other periods of the year, we see migration. We were able to prove that a lot of young fish are migrating downstream. So that has to be taken into account, and therefore the facilities have to be of a proper size. And at the Mura River, we found that they use the downstream, the upstream migration facility for downstream migration. But this is case specific. In that case, it would be appropriate to install a screen here so that the fish would be directed into the fish facility. It might work here and it might not work in other cases, and you would have to build a different system. But in view of upstream migration monitoring, we found that the fish used different options, and therefore we thought we should work in that direction. And in my last part, I'm covering some innovative solutions. Why do we need innovative solutions? Well, we need innovative solutions where downstream migration facilities don't exist, but we also have existing facilities where it is impossible to build a bypass stream or a creek, or where there is no space for a classical fish pass. And then new ideas would be appropriate. Bernhard Monay developed an idea. He's present today as well, so you can ask him. This is a first pilot study. It's a combination of lift and collection chamber, but you are not raising the basket with ropes or chains, but you fill it with water. Thus, the water level is raised. And you would have to use, of course, attraction flows similar to the traditional fishways. But we are only at a very early stage, and therefore I can't make any final statement. Another idea that we published and developed together with the University of Innsbruck is the rope-type screen, because in large rivers there are limits to screens. And this rope-like screen means that there are ropes across the river. It is said that this works with a distance of 100 meters. Then these ropes can be tight or can be relaxed because of drifting wood or whatsoever. And in cases of flood, I can actually lengthen the ropes so that they would settle on the bottom. Of course, this has to be shaped in accordance with some biological requirements. The relevant angle has to be taken into account in order to guide the fish into the right direction. This sounds a bit crazy. There are some lab tests. It seems to work quite well, but what we still need to prove is the fish. So we want to do some tests in order to find out whether these screens with the ropes are also accepted by the fish. This is my last innovative solution. This is the Albrecht fish lift inside solution. A very hard-working inventor from Lower Austria thought about it. I'm quite sure that you know the Archimedes screw, which is also utilized for some turbines. And he combined that with a lift system. So this screw consists of two systems. There is an outer screw with inflowing water, turning the entire screw, and there's an inner screw which is practically pumping the water upwards. So this is also used for other pumping systems and for other materials. This was built, there's a small river in Lower Austria. Here you see the experimental Albrecht fish lift. It was studied, and maybe you can start the video. I don't think I can manage from here. So you see the upstream migration. This is not an alternative to the near-natural fish path because it's a very technical solution. But if there is no room, if you are in the middle of the city with walls to the right and to the left, and you've got no chance at all to guarantee upward migration, it's very convincing. Because here you've got the attraction flow, and they're actually sucked into the water because the water is moving upwards. So this is quite clever. And if you take a look, the fish will get out unharmed. We did this with trout and other fish, and even with Danube salmon up to a size of 1 meter. So it's just a matter of size. Of course, the screw can have a big diameter. So there's no limit. It is just the height of the weir which might create any problems or limitations. And maybe we can switch to the next video. What is very interesting is the fact that this can be utilized also for downward migration, downstream migration. You see the outer screw that is driven by the water. The water is therefore utilized also for tailwater provision. So every problem is covered, therefore. So economically, it is quite convincing. You must imagine the water that is pumped upwards means that there is a certain energetic loss, but it is used again by the turbine. It's almost a perpetuum mobile, almost. When we talk of innovations, you've got to be careful. What makes sense, biological sense? Trap and truck is very often utilized at the Moselle River for the eel. For a transitional period, that's fine, but we have to develop solutions that work independently and under different political and economic framework conditions. Political framework and economical framework conditions, well, they're different for tropical countries. This is the Mekong River, the biggest power plant, and I was one of the experts for the environmental compatibility test. It's being built, and I read recently that they awarded a contract for $20 million for a fish pump. So I think there are limits to innovations, and you have to be very careful and think of the needs of the fish and the different fish species. But the final question that we have to ask ourselves is, and this is true today in 5 years or 10 years, or within the framework of the Water Framework Directive, where we have to develop management plans to assess whether our measures have an effect. We've got 1,000 fish passes. We'll build a few more. Does that mean, do we achieve the good ecological status after having restored continuity? Well, we have a lot of rivers that do not have a good ecological status, 2/3 actually. So they have to be restored. And if all of these rivers are integrated into a graph, giving you the ecological status in 5 categories, it is clear that we have hardly any problems where the situation is good or high. But in stages or categories 4 and 5, we've got water abstraction, we've got impoundment, we've got hydro-peaking, we've got channels. So there are multiple burdens and problems, meaning that we don't have a good ecological status. And we have the interruptions of connectivity, so there is no connectivity. And what happens if we solve one problem, connectivity? The graph won't be different if I don't solve the other problems. And therefore, it was important to listen to the discussion this morning. Switzerland is going for an integrative solution. They're taking into account morphology and other problems. So will we manage? It's a matter of time and money. In Austria, money is getting ever scarcer recently, and we've got considerable problems with morphology. There are a number of live projects where measures were taken, but ambitions are relatively low at political level with respect to the morphology and the solution for morphological problems. So in the last 6 years, it was about the restoration of continuity. We focus on our fish, the middle distance migrators, and as a matter of fact, we're only starting to examine this systematically now. We need innovative solutions, and we should never ever forget about all of the other problems. Thank you for your time.